sedikit. Tinggal match.
You love him.
Other
Hey.
Adela, what?
What? What's wrong, Coach?
That one.
Allah, this thing has said that please wait. This thing. Are you young?
Adela, you people are making noise.
No, not us now. It's our roommate.
What thing now? What thing? What thing?
You go to your room.
Adela.
Adela is disturbing.
This is not a talking center.
Gawe.
You think this is your grandfather's house?
Adel.
Yes?
Adela, will clap.
Not me. You ask Adela.
Adela.
I'm not talking
Adela.
with Adela. I want talking.
Anji? Yeah. Kaiser, man.
Adela.
Anji?
Media magic. You are making noise.
Not the one who's the
Go to your room.
Why are you people attending together in one place? Go to your room.
We love ourselves.
Who do you
My
think
love
is
for Adele will never die.
Who do you think is themselves?
You before you.
You and Maju. That's on coronavirus.
You and Majo?
You, Maju.
Work married?
Oh, Mara.
I will love us up more than you do.
Are you together now?
Adel.
No, we are not together. Majo is in hostel and I'm at home.
Take your bonus to Australia.
What are you doing at home?
What are you going to tell the man?
Nadi. Dengar.
Ali, why the class is not starting?
Adel,
Yes.
muchak ta.
Among aja.
Adel ay kamay.
Assalamu alaikum. Please, I don't want to mute all of you because when I mute you, I will not be sure if you are hearing me or not. So I don't want to mute anyone. So please keep silent because if I mute you, I will not be able to admit any person because I must admit every one of you one by one. The system had it changed. When I start a slide share, when I start a screen share, I cannot admit any more person. So no more one can join the meeting. If I start screen share, no one will be able to join the meeting, okay? Please keep silent so that if anyone does not understand anything, he can ask me every now and then. Please don't speak and keep silent. I will start the screen share, okay?
Okay, doctor, thank you.
Okay, I will not be able to admit any person. No person will be able to join the meeting anymore because the system to give permission for admission. To give permission for admission to join the Zoom meeting. I will not be able to admit any person when I start screen share. Okay? Okay, please keep silent so that I will not mute you all. Okay, there are 31 attending the meeting. If anyone is not able to attend, he will see the record. Last time we have not finished the glycogen storage disease. As I said, for all of you, you have to study the handout only. Don't study the book. We have one disease only in the glycogen metabolism. Please try to attend the next lecture on Saturday because I will stress on the important subjects that will come in your exam. I will give you a notification about the important items to be studied for your exam, okay? Do you hear me? Is it clear?
Yes, doctor.
Yes. The
Yeah.
glycogen storage disease has another name, glycogenosis. Glycogenosis or glycogen storage disease. These are metabolic diseases. Metabolic disease means a disease in metabolism. There is mutation in the enzymes of either glycogenolysis or glycogenesis. In the enzymes which sensitize glycogen or the enzymes which break down glycogen. And there is also mutation, maybe mutation in glycolysis enzyme. What are the sequences of these mutations? Abnormal quantities of glycogen are deposited in the liver, in the kidney, in the heart, in the skeletal muscles. If there is any defect in the enzymes that break glycogen, that break down glycogen, glycogen will be accumulated in the liver, kidney, heart, and muscles. Or accumulation of abnormal forms of glycogen, not the normal structure of the glycogen. There are many diseases. We are going to study one disease only. This is type 1 von Gierk disease, okay? Type 1 von Gierk disease. This is the commonest type. We are going to study this type only, the common type, okay? You have to know which enzyme has mutation. The enzyme which has mutation is glucose 6-phosphatase. I hear some noise. Please shut down your microphone. There is some noise, or otherwise I'm going to mute all of you. There is defect in glucose 6-phosphatase. If you have any radio or television or TV or any instrument beside you, please shut down any instrument because there are noise. Do you hear this noise?
Yes, yes,
Should I mute all of you?
yes, doctor.
Yes, doctor, mute all of us.
Just mute.
There is defect in the enzyme which is glucose 6-phosphatase. No, I'm going to stop and mute. The manifestation include fasting hypoglycemia. We are going to discuss why there is fasting hypoglycemia, lactic acidosis, accumulation of lactic acid, hypertriacylglycerolemia, elevation of triacylglycerol, elevation of lipids, hypercholesterolemia, elevation of blood cholesterol, fatty liver, accumulation of abnormal quantities of fat in the liver, hyperuricemia, elevation of the blood uric acid. Why all these things occur? Due to deficiency of glucose 6-phosphatase enzyme. There is impairment of glucose 6-phosphatase which breaks phosphoric acid, separate phosphoric acid from glucose 6-phosphate. This enzyme is found only in the liver. If I don't have 6-phosphatase, phosphoric acid will not be separated from glucose, so glucose will not come out from the liver cell to be secreted in the blood. Because in glycogenolysis, glycogen is broken into blood glucose, broken in the liver, and the liver secretes glucose into the blood. Okay? If we don't remove phosphoric acid from glucose, glucose will not come out from the liver cell and go to the systemic circulation. We don't study gluconeogenesis yet. There is impairment of glycogenolysis, impairment of the breakdown of the glycogen, and also impairment of the process we are going to study today called gluconeogenesis. Why? Because glucose 6-phosphatase enzyme, which separates phosphoric acid from glucose, is important in gluconeogenesis, works in gluconeogenesis, and important for glycogenolysis. If glucose 6-phosphate does not go out from the liver cells and go to the blood, it will be oxidized in glycolysis and produces lactic acid, and there will be elevation of the lactic acid inside the cell. Because glucose does not come out from the liver cell and secreted to the blood, it will be accumulated in the liver cell, oxidized by glycolysis into lactic acid. Why there is elevation of the triglycerides or the natural fat or the lipids, okay? Why there is elevation of the triacylglycerol? If we don't break glycogen into glucose, there will be hypoglycemia, fasting hypoglycemia. Why we need to break glycogen? Because when you stop feeding at night, after you get your dinner, we are going to stop feeding for about 8 or 10 hours, okay? So, blood glucose comes from breakdown of the glycogen stored in the liver or the liver only, to a less extent in the kidney. If we don't break glycogen into blood glucose, there will be fasting hypoglycemia. Muslims are accustomed to fasting during Ramadan months. In Ramadan, Muslims stop food for about 17 hours, 16 or 17 hours. Blood glucose comes from breakdown of the glycogen. So, if there is deficiency in glucose 6-phosphatase, there will be hypoglycemia, means lowering of the blood glucose. This will stimulate lipolysis. breakdown of the lipid in the adipose tissue. If we don't have glucose in the blood, lipids will be broken to release fatty acids in the blood so that many organs will start to oxidize fatty acid to get energy. Okay? Fatty acids will go to the liver. The liver will sensitize triacylglycerol from excess fatty acid, which is liberated from the adipose tissue, and sensitize one type of lipoprotein, which is VLDL. VLDL is a form of lipid which is surrounded by protein called lipoprotein. This particle, which is lipid surrounded by protein, carry triacylglycerol. The liver will sensitize triacylglycerol and surround it by protein. So the liver sensitizes very low density lipoprotein and secrete it in the blood. And this leads to elevation of triacylglycerol. There will be impairment of gluconeogenesis. We are going to discuss gluconeogenesis today. Gluconeogenesis means the synthesis of glucose from non-carbohydrates, such as proteins. This occurs during fasting, during prolonged fasting. The process of gluconeogenesis needs glucose 6-phosphatase. And here in this type of disease, the glycogen storage disease type 1, we don't have glucose 6-phosphatase, so gluconeogenesis will be stopped or will be impaired, is not functioning. There will be also elevation of the uric acid in the blood. You have studied hexose monophosphate pathway with Dr. Reham, pentose phosphate pathway with Dr. Reham. There is impairment of glucose 6-phosphatase. Phosphoric acid will not be separated from glucose, so glucose 6-phosphate will be shifted to hexose monophosphate pathway. This hexose monophosphate pathway will stimulate protein synthesis. Protein synthesis will be broken into your purine synthesis. Purine, that is adenine and guanine. We are going to study purine in a separate chapter, synthesis of purine, which are adenine and guanine. Of course, you know adenine, guanine, cytosine, thymine, uracil, which enter in the structure of DNA and RNA. These are nitrogenous bases. Glucose 6-phosphate accumulates in the liver cell, will be shifted to hexose monophosphate pathway. This will be directed toward purine synthesis, which is adenine and guanine. Purine is metabolized into uric acid. Excess uric acid will be secreted in the urine. So we have hyperuricemia. So accumulation of glucose 6-phosphate will lead to elevation of the uric acid and elevation of the lactic acid, because glucose 6-phosphate will be oxidized by glycolysis to give pyruvic and lactic acid. Lactic acid makes compete with uric acid for the renal excretion. So uric acid is much more higher than lactic acid. There is competition between them. So lactic acid will displace uric acid. So uric acid cannot be excreted in the urine. So there will be elevation of uric acid in the blood. Again, lactic acid will prevent uric acid from excretion in the kidney because there is competition between them. So there is elevation of uric acid. Okay, I will repeat again sequentially. Fasting hypoglycemia. Why there is hypoglycemia? Because there is deficiency of glucose 6-phosphatase. This enzyme is essential in breakdown of the glycogen, glycogenolysis, essential for gluconeogenesis. Gluconeogenesis is the synthesis of glucose from non-carbohydrate source. If we don't break down glycogen during fasting, if we don't sensitize glucose during fasting, there will be hypoglycemia. Deficiency of glucose 6-phosphatase lead to accumulation of glucose 6-phosphate in the liver cell, which will be shifted toward glycolysis and oxidized to form lactic acid. So there will be lactic acidosis. If we have hypoglycemia, this will stimulate lipolysis by elevation of the epinephrine. This is a stress. Hypoglycemia is a stress. Elevate epinephrine from sympathetic nervous system and lead to lipolysis, breakdown of the lipid in the adipose tissue. Fatty acids will be liberated and translocated to the liver. The liver sensitized a particle called very low density lipoprotein. This particle contains triglycerides surrounded by a protein. This particle is rich in triacylglycerol. So there will be elevation of triacylglycerol, which are secreted to the blood, and the liver secretes these particles. Of course, I said there is impairment of gluconeogenesis. Hyperuricemia. Why there is hyperuricemia? Excess glucose 6-phosphate will be shifted toward hexose monophosphate pathway, and this will lead to excessive synthesis of purine. Of course, this is an intermediate compound you are going to study in purine metabolism. Purine are adenine and guanine. The breakdown of purine will lead to the formation of uric acid. So excess amount of purine lead to excess amount of uric acid, and lactic acid, which is present in this condition, will compete with uric acid. So uric acid will not be excreted in the urine. There will be hyperuricemia. This will stop this lecture, and I will stop share and ask you. Is everything clear in glycogen storage disease?
Yeah, it's clear.
Anyone have
Doctor.
any question? I will admit the others. Of course, I cannot admit anyone when I make screen share.
Yes.
I cannot admit any person when I make screen share. Anyone want to ask anything? Allow the rest of the students. Allow them. Okay. When I start to screen share, I will not be able to allow to admit any person to join the meeting. When I start screen share, please stop the noise. I have to mute all of you. You are excess noise. Okay, I have to mute all of you. Okay, I will mute all of you. الكل سكرين شير. لا ده صعب جدا جدا جدا. شير. Today we are going to explain gluconeogenesis. What is gluconeogenesis? Gluco means glucose. Neo means new. Genesis means synthesis. Synthesis of new glucose from non-carbohydrate. Non-carbohydrate may be proteins, may be lactic acid, may be lipids. We are going to discuss how this occurs. Why the body sensitizes glucose from non-carbohydrate. This occurs during fasting. If you stop feeding for more than 18 hours, if you don't take any food for 18 hours, all the liver glycogen will be depleted, will be exhausted. So the body needs glucose. The body will break the muscle protein and takes amino acid to sensitize glucose from the proteins mainly. But actually this process starts 4 to 6 hours after the last meal and continues throughout the fasting state. We're going to discuss the precursor. What are the precursors? These are the building molecules from which we sensitize glucose. We can sensitize glucose from lactic acid, from pyruvic acid, from glycerol. I will discuss all that, from alpha keto acids, which are derived from amino acids. Okay? Of course, I discussed when the liver glycogen is depleted. Depleted means the liver glycogen is exhausted and has been used and is finished. No liver glycogen is found in the liver. This occurs after 18 hours of fasting. Gluconeogenesis has to supply blood glucose. Okay? Brain, as I said, brain and the RBCs, red blood cells, depends only on glucose to get energy. They cannot metabolize fatty acids. Most body can metabolize fatty acid, oxidize fatty acid to get energy, such as cardiac muscles, skeletal muscles can oxidize fatty acid to get energy. How can this process occur? This process occurs mainly in the liver. I can say it is only in the liver, to a minor extent in the kidney. Why it occurs mainly in the liver? Because of the presence of glucose 6-phosphatase and fructose 1,6 biphosphatase. How the process occur? By reversal of glycolysis. Of course, you must have studied glycolysis. If you don't study glycolysis, you will not understand the gluconeogenesis lecture. Never. Because it is a reversal of glycolysis. In glycolysis, we have 3 irreversible enzymes. The first is glucokinase. Glucokinase, which bind phosphate to glucose to sensitize glucose 6-phosphate. We need to reverse this step by glucose 6-phosphatase. Glucose 6-phosphatase removes the phosphoric acid from glucose, but glucokinase binds phosphoric acid to glucose. So in glycolysis, we bind phosphoric acid to glucose, but in gluconeogenesis, we remove phosphoric acid from glucose by glucose 6-phosphatase. The process of gluconeogenesis occurs by reversal of glycolysis. What is the reversal? The last step of glycolysis, we have pyruvic or lactic acid. If you reverse all enzymes of glycolysis, go from the last step to the previous until you get glucose, okay? You go from the enzyme number 10 and then you go back to enzyme number 9, to enzyme number 8, to enzyme number 3, number 2, number 1, until you get glucose. Reversal of glycolysis, we have 3 irreversible reactions. These are glucokinase, phosphofructokinase, pyruvate kinase. What do phosphofructokinase do? Bind phosphoric acid to fructose 6-phosphate to get fructose 1,6 biphosphate. Phosphofructokinase 1 binds phosphoric acid to carbon number 1 of fructose 6-phosphate to get fructose 1,6 biphosphate. The enzyme is called, which reverses this enzyme, fructose 1,6 biphosphatase. Tase means hydrolysis, removal of the 2-phosphoric acid. Okay, so in glycolysis, we bind phosphoric acid to glucose and to fructose. In gluconeogenesis, we remove the phosphoric acid from either the glucose or fructose. We are going to discuss pyruvate kinase. It is somewhat difficult because it is reversed by 2 enzymes. Pyruvate kinase is irreversible reaction in glycolysis. It has to be reversed by 2 enzymes, pyruvate kinase, and the other enzyme has very long name. Phospho, we get capital P. Enol, we get E. Pyruvate, we get capital P. Carboxykinase, we get C. We are going to see it in the diagram. Pyruvic acid will go from the cytosol, this is the cytosol, will be translocated across the inner, this is the inner mitochondrial membrane. I'm going by the mouse around it, this is the membrane. Pyruvic acid will be translocated from the cytosol and go to the mitochondria. The mitochondria, this is the area which is found in yellow color. Inside the mitochondria, we have carboxylase enzyme. Carboxylase binds carbon dioxide, okay? Carboxylase binds this is carbon dioxide. If we bind carbon dioxide to pyruvic acid, we will get oxaloacetic acid. Carboxylase enzyme needs biotin and magnesium. Pyruvate carboxylase binds carbon dioxide. We are going to go out from the meeting within few minutes. 40 minutes time limit on your group meeting. Love it. Okay. Okay. Pyruvic acid. We bind carbon dioxide to pyruvic to get oxaloacetic acid. Okay? This enzyme is very important. This is a key enzyme in gluconeogenesis. It needs biotin, one member of vitamin B complex. It needs magnesium. We get oxaloacetic acid. Oxaloacetic acid cannot go out across the inner mitochondrial membrane. Cannot cross the inner membrane because the inner membrane is impermeable to oxaloacetic. So oxaloacetic will get two hydrogen from NAD. If we add 2 hydrogen to oxaloacetic, this is a reduction. If we add 2 hydrogen to oxaloacetic, we will get malic acid, which is malate. Again, pyruvic is converted to oxaloacetic. Oxaloacetic gets a 2 hydrogen atom and converted to malate. This reaction is found in the citric acid cycle, called malate dehydrogenase. We add 2 hydrogen ions to oxaloacetic to get malic acid. Okay? Malate will go out from the mitochondria, go to the cytosol. I will stop here to ask you and to see if anyone needs admission. As I said to all of you, when I mute all of you, I cannot make admission for any person. And when I start screen share, I cannot make admission. There are much more noise. Much noise. I cannot withstand this noise. If everything is here, I will stop. Please, can you stop, please? I will mute you. Is everything clear?
Yes, ma'am.
As you see, malic acid will go out from the mitochondria to the cytosol, and then we reverse the reaction by malate dehydrogenase. We remove hydrogen from malic acid to get oxaloacetic. Why we sensitize malic acid? Because malic acid is allowed to cross the mitochondrial membrane, but oxaloacetic is not allowed to cross the mitochondrial membrane. So oxaloacetic must get hydrogen to be converted to malic. Malic will cross the mitochondrial membrane, and then we remove the hydrogen atom from malic to regenerate oxaloacetic. And this is a very complicated enzyme, which is called phosphoenol pyruvate carboxykinase. مش عارفة يصير في بالي دي. المهم phospho, I will break the name. Phospho, you will get capital P. This enzyme has capital P. Phosphoenol. En means double bond. You will get E. Enol. Pyruvate. In pyruvate, you will get capital P. PEP means phosphoenol pyruvate. En means double bond. Ol means alcohol, hydroxyl group. Pyruvic acid. So you know what did the name come from? PEP. Carboxykinase. We get from carboxy capital C. Kinase we get capital K. So this is very long enzyme. You have to study its name by the abbreviation. Phospho, we get capital P. Ene, we get E, capital E. Pyruvate, we get capital P. Carboxy, we get capital C. Kinase, we get capital K. What this enzyme do? Convert oxaloacetic into phosphoenol pyruvic. What is phosphoenol pyruvic? This is an organic acid found in glycolysis. So I am now inside glycolysis. If we reverse glycolysis, go backward. We go from the back enzymes, from the last enzymes, and you go to the first enzyme. You will get glucose. Okay? And this is the process of gluconeogenesis. Again, I will function here. If you look, intermediates of the citric acid cycle, all amino acids, glucogenic amino acids, which gives you glucose, will give me intermediate molecules of the citric acid cycle, such as alpha-ketoglutarate, or succinic, or fumaric, or oxaloacetic, or malic. And we have amino acids which gives the pyruvic. We have also amino acids which can give me pyruvic acid. Okay? By reverse, this intermediate compound will pass in the citric acid cycle until we sensitize malic acid, because malic acid is one of the intermediate molecules of the citric acid cycle. I will repeat again. Some amino acid give me pyruvic. This is pyruvic. Pyruvic will enter the mitochondria. By pyruvate, carboxylase. Carboxylase binds carbon dioxide. Convert pyruvic into oxaloacetic acid. Oxaloacetic is not allowed to cross the mitochondrial membrane. So, oxaloacetic will get hydrogen from NAD, to be converted into malic acid by the enzyme malate dehydrogenase. Malic acid or malate is allowed to cross the mitochondrial membrane and to go outside to the cytosol. Outside in the cytosol, malic acid we will remove hydrogen from malic acid to regenerate oxaloacetic acid. Oxaloacetic acid by a complicated enzyme called phosphoenol pyruvate carboxykinase, PEPCK, will form a phosphoenol pyruvic. Phosphoenol is intermediate molecule in the glycolysis. This is an organic acid which is found in glycolysis, so we can reverse glycolysis and sensitize glucose. What are the substrates? The substrates are the precursor from which we can sensitize glucose, or the building unit from which we can sensitize glucose. How glycerol will give me glucose? Glycerol come from hydrolysis of lipids. This is a glycerol. This is a building unit of lipids, of the fat. Glycerol, if we bind phosphoric acid to glycerol by glycerokinase, kinase bind phosphoric acid to glycerol. This enzyme is found in the liver to a very minor extent in the kidney. So the kidney is not very active in gluconeogenesis. We have phosphoric acid bound to glycerol. This is called glycerol phosphate. If we remove hydrogen, 2 hydrogen atom from glycerol phosphate, we get dihydroxyacetone phosphate. If you study glycolysis, you know that dihydroxyacetone phosphate is an intermediate molecule in the glycolysis. By reversal of glycolysis, you will get glucose. So this will show you how lipids give me glucose, how fat give me glucose. Again, glycerol comes from hydrolysis of fat, from the lipids, triacylglycerol. We bind phosphoric acid to glycerol to get glycerol phosphate by kinase enzyme. This is kinase. And then if we remove the hydrogen atom from glycerol phosphate, we will get dihydroxyacetone phosphate. This dihydroxyacetone phosphate is an intermediate molecule in glycolysis. By reversal of glycolysis, we will get glucose. We have fatty acids which are called odd chain fatty acids. Odd means an odd number, like number 1, number 3, number 5, number 7, number 9. This is an odd number. By oxidation of the odd chain fatty acid, we get propionic acid, which when activated called propionyl CoA. Propionic acid come from oxidation of other chain fatty acid. But even a chain fatty acid never give glucose. Even means even number, such as number 2, number 4, number 6, number 8, 2, 4, 6, 8, 10. If we have fatty acid which have even number of carbon atoms, never give glucose, do not give glucose. But if we have fatty acid which has odd number of carbon atom, it will give me blood glucose by supplying propionic acid. By carboxylase enzyme. What is carboxylase? Enzyme which bind carbon dioxide. It will give me an organic acid called methyl malonic acid or methyl malonyl CoA. By another enzyme which is isomerase enzyme, need vitamin B12. Methyl malonic acid will be converted to succinyl CoA. If you look at succinyl CoA, this is an intermediate organic acid in the citric acid cycle. If you go through the citric acid cycle, succinyl CoA will be converted into malate. According to the previous slide, I will come to the previous slide. Malate, this is malate. Malate can go through this pathway and give me glucose. And give me glucose by reversal of glycolysis, okay? Of course, you have to understand and study step by step. This is a collection of all the glycolysis. If you look at glucose, glucose in glycolysis is converted into glucose 6-phosphate, either by glucokinase or hexokinase. The difference between glucokinase and hexokinase are written in your handout. How can I reverse this step? By another enzyme which is called glucose 6-phosphatase, which hydrolyzes phosphoric acid and removes phosphoric acid from glucose 6-phosphate, convert it to glucose. If you look at the other reaction, fructose 6-phosphate can get another phosphoric acid to be converted into fructose 1,6-biphosphate by the enzyme called phosphofructokinase. How can I reverse glycolysis? By another enzyme called fructose 1,6-biphosphatase. So these are enzymes of gluconeogenesis which reverse glycolysis. Again, glycerol comes from hydrolysis of triglycerides, from lipids or from fat. If we bind phosphoric acid to glycerol, we get glycerol phosphate. If we remove hydrogen from glycerol by dehydrogenase, we will get dihydroxyacetone phosphate. This is an intermediate molecule in glycolysis. By reversal of glycolysis, we get glucose. Okay? Pyruvic acid. Certain amino acids will give me pyruvic acid. Okay? And we have another amino acids give me intermediates of the citric acid cycle. Pyruvic acid accept carbon dioxide by carboxylase and we get oxaloacetic. Oxaloacetic by the complicated enzyme which I discussed, PEPCK, phosphoenol pyruvate carboxykinase, we get phosphoenol pyruvic acid. And then by reversal, this is a reversal of glycolysis, you will get glucose. Okay? All glucogenic amino acid, about 10 amino acid, will give me intermediates of the citric acid cycle, which are keto acids. All of them will be converted into oxaloacetic or malic, and then oxaloacetic by phosphoenol pyruvate carboxykinase will give me phosphoenol pyruvic acid. Okay, I will stop here and ask you. Is everything clear? Those who attend lately, is my sound clear, please? Answer me. If there is any defect, I don't hear any one of you.
Yeah, there is a network problem, or we don't know.
If everything clear, please answer me.
Yes, doctor.
Please, those who attend late, I cannot admit them when I make a screen share, because all of you will disappear from my screen. All of your name disappear from my screen, so I cannot admit any person. Those who enter lately have to hear the record. I will send you the record.
Okay.
Okay, because they come very late. I will complete the importance of gluconeogenesis. For every metabolic pathway, you have to know the function of this pathway. The function, this is called importance. Why this pathway occur in our body. Gluconeogenesis occur to maintain our blood glucose. As I said, we take dinner at about 9 or 10 o'clock in the evening. We take our last food in the evening at 10 o'clock. And then you sleep for about 8 hours to get up in the morning at 7 o'clock. So you will have 9 hours without feeding. Blood glucose will be supplied during this period from breaking down of the glycogen. The glycogen will be depleted and used and finished within 12 hours. After 12 hours of fasting, if you don't eat, all your glycogen, all of the glycogen in the liver will be used and finished. So we have to sensitize glucose, blood glucose from non-carbohydrate. One of your students or your colleagues asked, do we have reserve of protein? No, we don't have reserve of protein. The body breaks down the muscles, and this is a stress condition to the body. This is dangerous to break down the muscle protein in order to take protein to sensitize glucose from the muscle protein. This is serious. This is why the people who stop feeding for 1 month or 2 months for any reason, for political reason, for example, they die. Because if the body breaks down the muscle protein, this is a serious condition, very dangerous. So gluconeogenesis is a serious condition. This is a stress to the body because the body eats itself. The body begins to break down its own tissue. The function to supply blood glucose during long time fasting or starvation. During fasting or starvation or stress or prolonged exercise or any defect in the carbohydrate in the diet such as ketogenic diet. But actually the process of gluconeogenesis starts within 4 to 6 hours after fasting. Glucose is important for the brain. The brain cannot oxidize fatty acids because the fatty acid cannot cross the blood-brain barrier, cannot reach the brain. But all our muscles, such as cardiac muscles, adipose tissue, skeletal muscle can oxidize fatty acid to get energy. But the brain cannot oxidize fatty acid. The brain depends on glucose as the only source of energy. The brain, after 5 to 6 days of fasting, begin to oxidize ketone bodies. We are going to study ketone bodies in lipid metabolism. Importance of gluconeogenesis for the red blood cells. Glucose is the only source of energy for the red blood cells. The RBCs cannot oxidize fatty acids because RBCs does not have mitochondria, no mitochondria in the red blood cells. And fatty acid oxidation need mitochondria. So glucose is the only source of energy. There is something which is called basal glucose requirement. What is the meaning of basal? Minimal amount of glucose is needed in all the tissue. There is a certain amount of glucose to be supplied to all tissues in our body to sensitize oxaloacetate. Oxaloacetate is important for the citric acid cycle. And citric acid cycle is important for oxidation of proteins, oxidation of fat, oxidation of carbohydrates. oxidation of all food, glucose, carbohydrates, lipids, and proteins. So minimal amount of oxaloacetate must be present all the time for the function of the citric acid cycle, which is important to oxidize fat during fasting, oxidation of proteins during fasting. Oxaloacetate come from glucose, so we have basal, means minimal glucose requirement. Ketone body oxidation cannot proceed without minimal supply of glucose. Ketones are derivative from lipids, from fat. The fetus needs glucose only, and the newly born baby needs lactose to sensitize the milk for lactation. The last slide, removal of lactic acid from the blood. Lactic acid accumulates in the blood during prolonged muscle exercise. Removal of the glycerol from the blood. Glycerol comes from lipolysis. Of course, lactic acid, if accumulated in the blood, will lead to acidosis in the blood, and this is a dangerous condition. Glycerol must be removed from the blood because this is lipid. Lipid should not accumulate in the blood. Glycerol comes from lipolysis, taken by the liver and converted into blood glucose. I will stop here. Is everything clear?
Yes, doctor.
Yes, I will stop here and I will explain regulation of gluconeogenesis tomorrow. Please study glycolysis perfectly and citric acid cycle perfectly in order to understand gluconeogenesis, because this is a reversal of glycolysis and reversal of citric acid cycle. So if you don't study glycolysis and citric acid cycle, you will not be able to understand the gluconeogenesis. Your colleagues, students who were admitted lately, you will have to hear the record because they come late and I could not admit them to the meeting because I make screen share and all of you disappear from the screen share, all of your name. Okay, I will stop here and I will complete tomorrow. I will send you the link to complete the gluconeogenesis, okay? Thank you very much. Anyone want to ask me any question? What is the meaning of hostile students who are making noise? Who are the hostile students who are making noise?
That is a lie. That is a lie. Doctor is hostile. The one who are the hostile. This guy is telling us that. Okay, I'm going to leave now. And any question, please write on the WhatsApp group, and I will send you the record. Okay? Thank you very much and goodbye. Thank you very much. Okay, bye-bye.
Okay.
Okay, bye.
Bye for now. God bless you.
Okay.
Bye.
Thank you.